Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone.
Minutes ago, a new planet discovered by the James Webb Telescope may be a better home for life than Earth. Although several of these planets contain hidden seas, we used to believe that they were all made of ice. Consider this: a planet that is neither too hot nor too cold is found on 1 out of every 5 stars. The newly discovered planet, known as Glea 163c, is well situated to host life because of its proximity to its star. Let's explore the enigma of Glea 163c, a planet that appears to be ideal for life, or perhaps something far more sinister that we were completely unaware of. A planet where life may be possible in the past. It was thought that planets other than Earth were icy wasteland devoid of water and life. When it was discovered that several planets had seas beneath their frozen exteriors, this perspective was drastically altered. It's currently estimated that about 1 planet out of every 5 stars may be home to life, since it provides ideal temperatures and sizes for the kind of environment that life may thrive on. These worlds have land and water, which provide all the elements needed for life. Scientists are on the verge of making a significant discovery in space exploration. On a planet similar to our own, they have detected unusual signals that indicate we may not be alone. These planets are abundant in the cosmos and provide windows into the vast complexity of space, even outside the boundaries of our solar system. A peculiar signal that appeared to be coming from deep space was discovered during explorations and gave rise to the notion that life or other kinds of communication may yet exist there. This fascinating finding raised the possibility that there may be more life and diversity in the universe than previously thought. The hunt for planets similar to Earth made tremendous progress with the advent of the James Webb Space Telescope. This cutting-edge observatory is transforming the search for far-off worlds by using infrared light to go far into space. Among its many discoveries, Glea 133c, an exoplanet, is particularly noteworthy. Located inside its star's habitable zone, it may provide favorable circumstances for sustaining life. This planet is considerably more than just a dot in space. It is an essential component in resolving the long-standing puzzle of whether or not humankind exists alone in the cosmos. Its discovery provides a wealth of educational possibilities and may pique the interest of more people in astronomy. Instructors may incorporate this fresh knowledge into their teachings, enabling learners and the general public to share in the thrill of recent space explorations. Such planets might harbor life, adding to the sense of realism in space research and illuminating the ways in which astrophysics and other related fields impact the environment. This sort of finding also makes science more widely known through the press and other media, which makes astronomy more approachable and fascinating for everybody. Its investigation is barely getting started. Plans for further missions, which seek to investigate the planet even further, are beginning to take form as more data is gathered. These missions are anticipated to confirm current discoveries and explore the planet's atmosphere in greater detail. By employing cutting-edge methods like spectroscopy and improved imaging, scientists hope to get a deeper comprehension of the planet's surface and climate. In order to get closer to deciding if it might really support life, these activities are essential. Its exploration has inspired scientists to create new models and ideas that advance our knowledge of far-off worlds. Through the analysis of observatory data, astronomers are reassessing what conditions are necessary for a planet to be habitable. These days, it's thought that elements like distinct chemical compositions and possible geothermal activity are essential for maintaining life forms that may be very different from earthly ones. The knowledge gathered from it is being incorporated into more general space exploration, indicating that mankind could be about to find new habitats that support life, which would completely alter our understanding of life as we know it. The star Betelgeuse, which is well known for its intense brilliance and is visible to the unaided eye, had a notable reduction in brightness that attracted notice from all across the world. The dimming was a significant decrease from the typical luminance levels seen, not a little oscillation. Although Betelgeuse's brightness has fluctuated in the past, according to historical records, the magnitude and speed of this most recent lowering were remarkable, arousing both wonder and worry throughout the astronomy community. Observatories from across the world pointed their telescopes toward the star, wondering if this sudden and dramatic shift would be a hint of something big about to happen, like a supernova. Being one of the red supergiants most often observed, Betelgeuse's peculiar behavior offered a rare chance for scientists to learn more about the traits and life cycle of such enormous stars. This incident highlighted the dynamic and perhaps surprising character of stellar activity in addition to raising scientific awareness. Still, the most surprising thing about the incident was not Betelgeuse's notable fading. People all throughout the world were excited about the possibility of seeing a supernova, an event that many view as a once-in-a-lifetime experience. As Betelgeuse's brightness decreased, astronomers began to wonder if they would soon be able to see an event as massive as this. However, there were several difficulties in precisely estimating Betelgeuse's size and distance. The star's inclination to vary in size made it difficult to take accurate measurements. Moreover, the occurrence of limb darkening, which is characterized by the star's brightness appearing to diminish at its periphery, made it more challenging to determine its actual size. These difficulties highlighted the difficulties of researching such erratic celestial entities. Apart from the difficulties in determining Betelgeuse's size, the precise separation of the star from Earth is still unknown. It is estimated to be between 433 and 724 light-years distant, while future technological developments may allow for more precise calculations. Despite these challenges, Betelgeuse's amazing characteristics have been revealed by modern telescopes. Interestingly, the star has ejected at least 6 layers of material throughout time, encircling it. These expelled shells contribute significantly to our knowledge of stellar evolution by shedding light on how stars lose mass and the activities that take place at different stages of a star's existence. We then look toward a star that might brighten the sky. In the far future, Betelgeuse has the potential to burst into a gigantic supernova, which would alter the whole night sky. When a star runs out of fuel, it explodes, releasing a massive quantity of energy, and becomes a supernova. In the case of Betelgeuse, its core becomes unstable as it burns through lighter elements like hydrogen and progresses to heavier ones like helium, carbon, and ultimately iron. The explosion is caused by the collapse of the star's core, which can no longer sustain the weight of the star. This supernova may be so brilliant that it might be seen during the day and surpass the brightness of all other stars in the sky put together. Betelgeuse is almost 600 light-years distant, so despite this incredible occurrence, Earth would not be in danger. By the time any radiation or particles from the explosion got to us, they would be too feeble. Therefore, even though Earth won't be impacted, astronomers will be treated to a breathtaking vista, and scientists will have the unique opportunity to closely examine such an event. We have an ideal, risk-free chance to learn more about supernovas because of this distance. But that's not where the narrative ends. Betelgeuse is a special example that provides a unique window into the life of a star that is almost dying. It began like other stars, burning hydrogen in its core to produce helium and release massive quantities of energy. Betelgeuse entered a new stage of life as a result of depleting all of its hydrogen as it grew older. This was a critical stage where the star's size and energy output altered as it started fusing heavier elements. Betelgeuse's surface has cooled, its size has grown, and its brilliance has become more erratic, which is why it is currently a red supergiant. However, even heavier elements, such as iron, have been included. In contrast to previous fusion processes, the process of making iron consumes energy rather than releases it. This indicates that Betelgeuse is becoming unbalanced. When there isn't enough energy to propel the star outward, gravity begins to draw it in, which causes it to collapse. This prepares the atmosphere for one of the most spectacular occurrences in a star's life, a supernova. Betelgeuse's outer layers will burst when it eventually runs out of fuel, momentarily outshining whole galaxies. By dispersing heavier atoms across space, this magnificent explosion will not only signal the end of Betelgeuse, but also aid in the creation of new stars and planets in the cosmos. Astronomers can better grasp how stars form and fade by examining Betelgeuse, which helps them comprehend the larger processes that create our universe. But this is only the start. With the advent of cutting-edge tools like the James Webb Space Telescope, researchers will have even more capacity to examine Betelgeuse and other red supergiants. We will be able to understand more about how stars lose mass and the precise moments before they burst thanks to these next-generation telescopes. Many more discoveries regarding the birth, growth, and death of stars will be made in the future, opening the door to a deeper comprehension of the most significant cosmic occurrences. We now have concrete evidence for the existence of black holes for the first time. This was no grainy snapshot, but a crisp, detailed image of the black hole's shadow set against burning, brilliant gas. The event horizon, the black hole's edge, became apparent to us due to the light that attempted but was unable to leave it. Across the enormous span of our Milky Way galaxy, hidden from view, there may be more than 100 million black holes. Let's investigate this intriguing theory and see what it has to say about the cosmos. A massive spiral of stars, gas, and dust is called the Milky Way. This spiraling galaxy has a large number of hidden black holes. Though it is difficult to locate them, scientists think that there may be more than 100 million of these cosmic objects. There is no direct visible light or radiation coming from a black hole. Their powerful gravitational attraction, which impacts neighboring stars and gas, is how we know they exist. As a result, black holes are the universe's most invisible things. What's even more intriguing is that the possibility that black holes exist within our galaxy alters our understanding of the cosmos. It affects our understanding of the evolution of stars, the motion of galaxies, and ultimately the ultimate fate of everything. One of the basic concepts in black hole theory is that they are formed from the remnants of enormous stars. Envision a star that dwarfs our sun in size. Its outer layers are thrown off as it bursts in a supernova when it runs out of fuel. The core is all that is left, and it collapses because of gravity. A black hole is created when a core with sufficient mass collapses into a point of infinite density. Beyond their formation, black holes have other aspects. The hypothesis was given a twist by mathematician Roy Kerr. He proposed that some black holes had extraordinarily fast spin rates. The ergosphere is a thin, disc-like structure that is formed around the black hole as a result of this spinning. Dragged by the whirling black hole, space and time begin to behave strangely in this region. Even still, this wasn't the most confusing aspect. Wormholes make everything even more bizarre. Think of spacetime like a flat surface. On this page, we typically go from one point to another. However, what if we could fold the sheet to make two far-off places closer together? A wormhole would operate as a space shortcut, similar to a tunnel that connects these locations. This hypothesis is based on Einstein's general theory of relativity, which states that spacetime may fold or bend under extreme circumstances, such as close to black holes. However, if wormholes are real, they may collapse the moment an object, even a single particle, tries to cross through them. Scientists are nonetheless quite interested in wormholes despite these difficulties. They arouse our curiosity in the greatest mysteries of the cosmos. Is it possible that they will someday let humans travel across stars or perhaps galaxies? Let's explore a fresh theory as we delve further into the wonders of space. The extra dimensions of string theory. This theory attempts to unify quantum theory, which describes the behavior of the smallest particles, with Einstein's theories concerning gravity. The premise behind superstring theory is straightforward yet profound. What if the tiniest particles, like as quarks and electrons, are actually tiny vibrating strings rather than microscopic dots? Particles have characteristics because of the way each string vibrates. It's similar to how various notes originate from distinct guitar string vibrations. The twist is that, according to superstring theory, there are other dimensions to the cosmos in addition to the 4 that we now know, 3 of space and 1 of time. It suggests that there might be 10 dimensions, the other ones being so tiny that they are invisible to us. Some of the mysteries of physics, such as the reason gravity is far weaker than other forces, may be resolved by these additional dimensions. According to this idea, other forces remain in the dimensions that are clearly observable. However, gravity seems weaker because it disperses over all 10 dimensions. However, this isn't even the most important query. Could the answer to unlocking even more enigmas about the functioning of the cosmos lie in these other dimensions? With a maximum speed of 700,000 kilometers per hour, the Parker Solar Probe is now the fastest spacecraft ever developed. It would still take more than 6.5 billion years to get to Proxima Centauri, the star that is nearest to Earth after the Sun, even at that pace. This illustration demonstrates just how enormous space is. It serves as a reminder that despite all of our technological advancements, we have only just begun to explore the cosmos. Though concepts like folding space and warp drive seem fascinating, the current state of affairs is very different. The vast distances between stars and planets in our cosmos serve as a constant reminder of how tiny and constrained we are. Current technology and our understanding of physics still limit our ability to build faster spaceships and realize our most ambitious plans to bend time and space. However, this isn't the most annoying aspect. We go ahead because of the sheer difficulty of these enormous distances. Every advancement we achieve builds upon the previous one. We get a little bit closer to our objective of exploring the stars with every new discovery or development. We gradually push the boundaries of what is feasible as one generation influences the next. As we look to Mars and beyond right now, we are reminded of how challenging it is. Once considered science fiction, the notion of transporting humans to Mars is now a reality because to the tireless efforts of space organizations and inventors worldwide. Mars stands for the next significant milestone in human space travel, a challenge that motivates us to continue exploring and aim for even farther off locations. However, this is not the hardest part. Finding a new home on Mars is only one of our goals. We also want to go on new experiences. It demonstrates our innate curiosity and desire to learn about and comprehend the world around us. It's about dreaming of a time when the stars are more than just far-off lights in the sky, they're destinations we can go to, and pushing the limits of what we can accomplish with technology and our creativity. The innovative concepts around interstellar travel are motivated by the same attitude. Researchers in science and engineering are investigating ideas like traveling faster than light or bending space-time that were once exclusive to science fiction. These concepts are more than simply wild speculations. They stand for our ambition to push the boundaries of our knowledge and envision unimagined futures. However, that's not even the most motivating aspect. The significance of missions such as the Parker Solar Probe becomes even more apparent as we approach these new problems. Not only do these trips increase our knowledge, but they also challenge us to dream greater and think beyond. They serve as a reminder that we should investigate the cosmos rather than merely watch it. We cordially invite you to join us for the next exciting chapter in human history. Mars and other far-off places become metaphors for our capacity to transcend our limitations as we travel further. They challenge us to reconsider what it means to travel, live, and find our place in the cosmos. By expanding our exploration, we make it possible for future generations to live and prosper in space, transforming science fiction from today into reality. Planets like Proxima b, which circle their stars relatively close, might lose their protective atmosphere because of strong radiation from neighboring stars. This is a serious issue since an atmosphere protects the planet's surface from solar and cosmic radiation in addition to being necessary for life support. It would be difficult for life to survive without this barrier. Even worse, compared to bigger stars, M dwarfs, which are tiny stars, remain active for far longer. This implies that it may spend billions of years in these harsh settings. Long-term exposure to solar radiation may pose challenges for the emergence and continuation of life on our planet. The star's frequent energetic outbursts may make it impossible for the planet to maintain a stable atmosphere long enough for life to flourish. If the planet's atmosphere has an ozone layer at all, it may be gradually destroyed by powerful particles from Proxima Centauri. The Earth would be exposed to harmful UV rays without the ozone layer, which might harm the DNA of any living things attempting to exist there. This presents yet another obstacle to conquer in life. Even in these harsh circumstances, there remains a glimmer of optimism. Extreme settings are known to support life on Earth, leading scientists to speculate as to whether such environments may support life in general. This planet is still a major target for investigation, and each new finding advances our knowledge of not just other worlds, but also the resilient and adaptive nature of life itself. The study of distant planets is being altered by cutting-edge devices such as the James Webb Space Telescope, which has unique instruments including the mid-infrared instrument and the near-infrared spectrograph, NIR-SPEC. These are not your typical telescopes, rather, they are extremely sophisticated devices that dissect light into its constituent components. Consider the possibility of life on Glea 163c. Could its discovery prove we are not alone in the universe? If you found our journey through space fascinating, consider the method called spectroscopy that allows scientists to find specific gases and other elements in the atmosphere of planets like Proxima b. Remember to like, subscribe, and leave a comment below with your opinions.